கோஹோஸ்ட் பண்ணிட்டேன். இப்ப பேசி பாருங்க. நான் பேசுறது கேக்குதா? நீங்க பேசுங்க.
ஹலோ, கேக்குதா சிவா? ஹலோ.
இல்லையே, அதுல கேட்க மாட்டேங்குதே.
நான் அன்மியூட் பண்ணிட்டேன் சிவா.
நான் பேசுறது கேக்குதாப்பா?
நீ பேசுறது எனக்கு போன்ல தான் கேக்குது.
ஹலோ மேம், வெரி குட் மார்னிங் டு ஆல்.
இப்ப கேக்குது.
Very good morning to all. Is my audio is clear?
Hello. ஒரே நிமிஷம் நான் திருப்பி ஜாயின் பண்றேன். ஒரே நிமிஷம்.
ஏன் என்னாச்சு? நான் உங்களுக்கு கோஹோஸ்ட் பண்ணிருக்கேன், நீங்க கட் பண்ணிட்டு.
இல்ல அது என்னோடது வரல. இல்ல என் பேர் வரல, திவ்யா சக்தின்னு வருது. அதனால நினைக்கிறேன். இருவ ஜாயின் பண்ணும்போது பாப்பா ஜாயின் பண்ணது அப்படியே ஜாயின் பண்ணிட்டேன் போல.
மேம்
ஓகே, இன்வைட் பண்ணிட்டு எல்லாத்தையும்
அது பாத்துக்கிறேன் நான்.
அட்மிட் ஆல் எல்லாம் கொடுத்துட்டே இருங்க, சரியா?
ஹலோ, குட் மார்னிங். Is it audible?
எனக்கு ஏன் ஆடியோ வரலன்னு எனக்கு தெரியலையே. ஹலோ
ஹலோ, எனக்கு அன்மியூட். உனக்கு வந்து அன்மியூட் பண்ண சிவா, மியூட்ல இருக்கு.
very good morning to all.
Okay. Hello, good morning to everybody. Am I audible Shiva?
எனக்கு ஆடிபிளா இல்ல மேம், பட் மத்தவங்களுக்கு எல்லாம் ஆடிபிளா தான் இருக்கு.
இல்ல நான் பேசுறது கேக்குதா?
நீங்க பேசுறது எனக்கு கேட்க மாட்டேங்குது. நம்ம பேசுறது எல்லாத்துக்கும் கேக்குது.
ஹலோ மேம், கலைசெல்வி மேம். ஹலோ, இப்ப நான் பேசுறது கேக்குதா சிவா?
எனக்கு கேக்கல மேம், பட் அவங்களுக்கு எல்லாம் கேக்குது.
அது எப்படி எனக்கு கேக்குற மாதிரி தெரியலையே. எப்படி கன்ஃபார்ம் பண்ண?
அது தெரியல, மத்தவங்களுக்கு எல்லாம் கேக்குது. சரி ஸ்டார்ட் பண்ணுங்க, என்ன பண்றது?
இல்ல நான் பேசுறதே கேட்கலன்னா எப்படி?
மத்தவங்களுக்கு எல்லாம் கேக்குது மேம், எனக்கு உங்களுக்கு மட்டும் தான் கேட்கல.
நீ பேசுறது எனக்கு சுத்தமா கேட்கலங்க.
அதுதான், நீங்க பேசுறதும் எனக்கு கேட்கல.
ஒரே நிமிஷம். ஹலோ கலை, நாங்க பேசுறது கேக்குதா? நான் டெஸ்க்டாப்ல தான் யூஸ் பண்றேன். கம்ப்யூட்டர் ஆடியோ இல்ல, ஆல்ரெடி கம்ப்யூட்டர் ஆடியோ கனெக்டட் தான் இருக்கு.
மியூட் பண்ணிட்டு ஆரோ கிளிக் பண்ணுங்க.
Same as system. சேம் as system செலக்ட் பண்ணியிருக்கேன். ஹலோ, am I audible now? இப்ப கேக்குதா? நான் பேசுறது கேக்குதா? ஓகே ஓகே. Hello, good morning to everybody. We'll start this session within 5 minutes. We'll wait for everyone to join.
Very good morning to all. I am Dr. Shivappriya. Does my voice is audible?
Yes, Shivappriya. So it's audible. Shall we start?
Okay.
Shall we start? Shivappriya.
I am Dr. Shivappriya, going to handle today's session on the topic of
Hello. Good morning
significance
to
of
everybody.
ANN and deep learning in image classification. I welcome all of you for this 1 week STTP on artificial intelligence in healthcare.
Excuse me. Shivappriya.
Is my screen is visible to you all?
Shiva, visible Shiva. Shall I start, Shiva? Shivappriya. Okay, so very good morning to one and all present here.
Is my screen is visible?
Shivappriya phone panna. ஒரு 2 நிமிஷம் கூட.
Today I'm going to present the topic on significance of ANN and deep learning for image classification. The outline of the presentation is artificial neural network, linear separable and non-separable problem, multi-layer perceptron backpropagation neural network, decision boundaries, iris flower classifier case study. Then we are going to see the deep learning MNIST data classifier case study, then stacked autoencoder and decoder. Finally, we are going to see the convolution neural network. You know that artificial intelligence, that is, we are creating intelligence artificially. That is called as artificial intelligence. AI is the study of idea that enable computers to be intelligent. Before going to see about artificial neural network, first we have to know about what you mean by neuron and how the neuron works. This is the functioning of the neuron, biological neuron, which consists of dendrites, soma, axon, and synapses. Dendrites accept the input, soma process the input, axon turns the processed input to output. Synapses will provide the electrochemical contact between the neuron, provides the electrochemical contact between the neuron. With this, the individual neuron is mimicked artificially, that is called as the artificial neuron. We are having inputs, axon, and the weights as synapse, and that weighted input is going into the summation process and then activation process with the help of soma body, which will fire the neuron. This is the functioning of a single neuron. These type of many neurons, millions of neurons are interconnected together, which will form an artificial neural network. Clear? We are going to mimic the brain single neuron as an artificial neuron. Then the artificial neuron is interconnected together, which form an artificial neural network. And we know that in general computer programming, we will frame an algorithm, then we will feed the input. For the algorithm, we will get the output. But in the artificial intelligence, instead of framing an algorithm, from the data set, the algorithm is developed. From the data set, the algorithm is developed. Then the developed algorithm, we are going to classify the data. Then with the developed algorithm, we are going to classify the data. Now I'm changing the screen. Is it visible? Any doubts and clarification means kindly put it in the chat box. Okay. Human intelligence, intuition and common sense, judgment, creativity, belief. Judgment, creativity, belief, or in the human intelligence that is mimicked artificially. That is called as artificial intelligence, which have the ability to simulate the human behavior and cognitive process, which is the ability to simulate the human behavior and cognitive process. Then the human intelligence have the ability to demonstrate their intelligence by communicating effectively. Artificial intelligence capture and preserve the human expertise. Human intelligence will have pulsable reasoning and critical thinking, but AI will have the fast response, the ability to comprehend large amount of data quickly. Human intelligence, they have limited knowledge base, but artificial intelligence cannot readily deal with mixed knowledge. Human intelligence will have the information processing of serial nature process, but here high development cost is required for the artificial intelligence. Humans are unable to retain large amount of data in the memory, but artificial intelligence will maintain or will memorize the large amount of data. Sorry, I have to enable all the participants who are all there in the waiting room. That's why it's getting delay. And also screen it's also changing. Image data pre-processing steps for the neural network. Neural network image recognition algorithm rely on quantity of data set. That is based upon the data only we are fixing it into the training and test data, and then we will model the algorithm. So that we have to pre-process the data correctly. In order to pre-process the data, first step we have to fix the image size. If it is an higher quality image, give the model more information, but requires more neural network nodes and more computing power to process. And the next one is the number of images. The more data you feed to the model, the more accurate it will be. But ensure the training set represent the real population. And we are having different types of images: grayscale image and RGB color image, 3-color images. Before going to the neural network process, we have to check all these details. That is aspect ratio, what is the image scaling, what is the mean standard deviation of the input data, and whether we have to do the normalization or not. Normalization is nothing but one of the method of normalization is we will find out the mean of the data, then standard deviation of the data, then individual pixel is subtracted by the mean, then we will divide it with the standard deviation, which frames the normalized image data. And if required, we can go with the dimensionality reduction process. Generally, for the normal artificial neural network, first I will explain about normal artificial neural network. In the normal artificial neural network, we will go with the data reduction process, because wider the dimension, which causes the cruise of dimensionality problem. So that in order to avoid that one, we have to reduce the dimension, so that with the minimum feature space, we can able to classify the data more accurately. So that we need to go with the feature reduction process. And in some cases, we require the data augmentation process. The data augmentation process involves that we have to do rotation, scaling of an image. Everything can be done under the data augmentation process. Like this, we have to pre-process our image. After pre-processing only, we can able to feed it into the neural network. With the pre-processed image data, we are entering into the neural network classification process. This is the Perceptron. Perceptron was developed by Frank, which is a simple feed-forward network. Which is a simple feed-forward network that can create a decision boundary. One second. I think now the screen is visible, because I am admitting the participants to the program. That's why I kept in the normal mode. Now we will see the perceptron network. In the perceptron network, we will have a single output neuron. That is, we can able to give the input from minus infinity to plus infinity, and then it is entering into the summation and activation process. Then it is entering into the output layer process. This is the insight of that particular perceptron network. We are having the input and the weight function. All the inputs are weighted, and the summation of weighted input is entering into the activation function. Here we are using the binary activation function, that is step function. Binary activation function means either 1 or 0, that particular representation. Here 1 or -1 representation. With the step function, we are going to linearly classify the given data. With the step activation function, we are going to linearly classify the data. This is the simple representation for the linear separable and also for the non-separable classifier. Mostly we will start with the Boolean function, and or not function can be classified with respect to linear separable classifier. I think the marker is visible to you. The marker is visible to you all. Here we are having the input. The number of input is equal to the number of input nodes in the input layer. The number of output is equal to the number of output nodes in the output layer. For the Boolean operation, if you consider the 2-input Boolean operation, we will have the XY input and then weighting operation, then it is entering into the summation, then finally activation operation, so that we will get the output. This is the and or not can be classified with the help of linear function, can be classified with the help of linear function. That's why it comes under the linear separable class. But the XOR problem cannot be solved with respect to linear separable line. We have to go with the non-linear separable line. That is, we have to go with the quadratic function. Then only we can able to classify the classes for the XOR function. The input, hidden node, then output. Input layer, hidden node, then output. Clear? So that for simple linear separable problem, we can able to go with the simple single layer neural network, feed forward neural network architecture. But to classify the non-linear problem, we need to go with multi-layer perceptron neural network. But to classify the multi-layer neural network, we have to classify the non-linear problem, we need to go with the multi-layer perceptron neural network architecture. This is the typical feed-forward network: input, input layer, hidden layer, output layer. Input, hidden layer, output layer. Input, weighted combination, summation of input and weighted. Then it is entering into the sigmoidal activation function. Then neuron output. Then this is final layer is the classification layer. Final layer is the classification layer. This is the overall structure of the multi-layer perceptron neural network. T input training set, M input layer node, then input to hidden layer, N hidden layer nodes, then N cross P weights. Because we are having P number of output layer node, N number of N number of hidden layer node, and M number of input layer. So that in between that we will have M cross N weights, and N to P we will have N cross P weights. N to P we will have the N cross P weights. Finally, we will have the target output. That is the multi-layer perceptron backpropagation neural network. That is, in the feed-forward neural network, input weighted combination, then it is going for the output layer. The number of features are given to the input layer. The number of classes are there in the output layer. Clear? So that we will compute the error value. Error value is target minus actual output. Then we will propagate the error backward towards the hidden layer to input layer, so that the weights are fine-tuned. Then with the fine-tuned weights, we are going with the again feed-forward process, so that we will get the output. If the actual output is reached the target value, we can stop the network training process. Then we can go for the testing process. Until that, we have to do the training process. Then how many nodes we can able to fix? As I already mentioned that the number of features is equal to number of input node. The number of output class is equal to number of output layer nodes. Then how we have to fix the number of hidden nodes in the hidden layer? How we have to fix the number of hidden nodes in the hidden layer? If you fix very minimum hidden nodes, which won't learn properly, as like in our figure 1. The figure 1, we are not having the proper learning process. But if you keep more number of hidden nodes, which causes more training, more learning process, that is overfitting process, which causes overfitting process, so that it is not generalized. The figure 3 is not generalized. The figure 1 is not learned properly. So that in between we have to fix the number of hidden nodes. In between we have to fix the number of hidden nodes. Clear? How we have to fix the number of hidden nodes? That is, in order to learn the data properly, we have to optimally fix the number of hidden nodes. We should not keep very minimum hidden nodes, and also we should not have more number of hidden nodes. If you have more number of hidden nodes, which will cause us the overfitting process, so that your data won't be generalized for the unknown input. If you have minimum number of hidden nodes, the data won't be learned properly. The network model won't be learned properly. So that optimally we have to fix the number of hidden nodes. This is the feature for the multi-layer perceptron. From the image we have to extract the features, then the features is going for the feed forward operation. So that features multiplied with the weight, then it is going for the summation activation function. Here, what's this activation function? This is an sigmoidal activation function. Sigmoidal activation is a non-linear activation function. Sigmoidal activation is a non-linear activation function. Tan sigmoidal also there. Tan sigmoidal will be zero centered. Zero centered. This is normal sigmoidal process, and we will get the output here. And we will get the output here. How the processes takes place: the input, weighted value, summed representation, then it is entering into the activation, then finally we are going with the final output layer process. So that the field class 0 1 representation for 0 class 1 class, 0 class 1 class. Training of the network, initialize with the random weight. We have to initialize with the random weight, so that the field class feed it through get the output. We have to feed it to the feed forward network to get the output. Compare with the target output. We have to compare with the target output. So that if we are getting the error, here we are getting the error. Error is 0.8 because the target value is 0, but our actual output is 0.8. So that error is 0.8. So that we have to modify the weight value. We have to fine tune the weight value. We have to adjust the weight value. Then again, we have to give the next input training data. Okay, next input training data. First we have given for the 0 class. Now we are giving to the first class. First class, we are getting the actual network output is equal to 0.9, but the target value is equal to 1. So that we have to compute the error. The error is minus 0.1. Then based upon the error value, we have to go backward, and then we have to fine tune the weight value. With the fine tuned value, we will go for the next data training process. With the initial random weight, the decision boundary is like this. By presenting the training data, second training data, and adjusting the weight, we are getting the decision boundary like this. By again adjusting the weight, and eventually, if we go for the weight adjustment, we are getting the final decision boundary like this. We are getting the final decision boundary like this, so that the blue is classified from the orange. If the f of x is a linear function, the neural network can only draw a straight decision boundary. If you consider the activation function as a linear activation function, for example, binary step function as an activation function, we can able to draw the decision boundary only like this, a single line. This single line cannot classify a non-linear data. So that in order to classify the non-linear data, compulsorily we have to go with the non-linear activation function. Clear? In order to classify the non-linear data. This is the simple example of a non-linear data. In order to classify this non-linear data, we required a non-linear activation function. This is with the help of non-linear activation function, how we are classifying the blue class from the orange class. SVM and all, we will map the features onto some other feature space. Again, we will draw a single linear decision boundary there. For the nonlinear problem, by increasing the number of hidden nodes in the hidden layer, we can able to do more accurate classification. This is a simple example for the 3 hidden neuron, how the classification takes place. If you increase the number of hidden neurons, it will try to fetch the features for the corresponding class. By increasing the number of hidden nodes, we can able to do the classification more accurately. More layers, more neuron can approximate more complex function. Yeah, the more layer, more neuron can approximate more complex function. This is the simple example. With the simple 3 number of hidden layer neuron, we can't able to classify this being pink color portions. By increasing the hidden neurons, we can able to classify the pink portions. Again, if you increase the hidden neurons, we can also classify the other portions. Then we will see what do you mean by overfitting. We have already seen the overfitting, underfitting process. Underfitting means high bias in the training. Overfitting means high variance. So that in between we have to have our classification process. Then only we can able to have good compromise. If you give any unknown input data, the network can able to classify the data. This is, if you draw the decision boundary for this particular data set, this is an inadequate classification process. For good compromise, we have to do the classification like this. If you have more number of hidden neuron, your network will accurately classify the first class from the second class, so that which causes the overfitting problem, so that it is not generalized properly. If any unknown input is given, this model cannot classify that particular data correctly. So that in order to classify the data correctly, you have to go with like this structure, middle structure we have to go. Learned hypothesis may fit the training data very well, even outliers noise, but fail to generalize to the new example. Overfitting fails to generalize. Underfitting won't have proper learning. Underfitting won't have proper learning. Overfitting won't have proper generalization. With the help of iris dataset, iris flower dataset, we are going to see the classification process. The Fisher iris dataset consists of 3 classes. The 3 classes are Citaso, Versicolor, Virginica. Each class hold 50 number of samples. Here, the 2 classes are linearly separable and other one is not linearly separable. So that we have to go with the non-linear separable classification process. Here, the iris flower is going for the multi-layer perceptron neural network process, so that from the image we have to extract 4 number of input features. That is sepal length, sepal width, petal length, petal width. This is the iris flower data set. Iris Citaso, iris versicolor, iris virginica, the features extracted from the flowers. That is sepal length, width, petal length, width. This is iris flower data set. Iris data from 4 characteristics of the flower. We can able to go with the classification process. That is, this is the distribution of data, Citaso, versicolor, virginica. How will be the petal length, petal width, and sepal length, sepal width. This is the data distribution for the 2 features, sepal length, sepal width. This is the data distribution for the sepal width and petal length. By seeing this image itself, we can clearly say that Citaso can be classified from these 2, linearly classified from versicolor, virginica. But versicolor, virginica will have overlapping classes, so that the linear classifier won't classify the versicolor and virginica. So that we have to go with the non-linear classification process. This is again the data distribution. That is for the 3 classes, how will be the data distribution, feature distribution for the petal length and petal width and sepal length, sepal width. X-axis hold the different flower classification, and the Y-axis will have the sepal length. Y-axis will have the sepal length. Sepal length, sepal width, iris cetaso-versicolor virginica. This is iris characteristics. We have extracted features from this image. From this image, these are all the features: sepal length, sepal width, petal length, petal width. For the iris cetaso, iris versicolor, and iris virginica. So that I already mentioned that input layer will have the number of features. Here from the image we have extract 4 number of features. So that the 4 number of features are going to the input nodes, input layer. Then it is going for the hidden node. Then it is going for the hidden node. Then finally the output layer. Then finally the output layer. Clear? So that the number of weights, if you see in between the input layer to hidden layer, we are having 8 weight value. Clear? 1, 2, 3, 4, 5, 6, 7, 8. And in between hidden layer to output layer, we are having 2 number of weights. Totally, we have to compute 10 number of weight value for this particular iris flower classification processor. This is the final trained network specification. Input layer will have 4 nodes, hidden layer will have 2 nodes, and output layer will have 1 node. Because among the 1 node, we have to classify if the value is 0, that can be stated as iris cetaso. 0.5 iris versicolor, 1 iris virginica. Like that we can able to classify, and I already mentioned that we have to compute 8 weight value between the input layer to hidden layer and 2 weight value between the hidden layer to output layer. Like this we have to frame the network. This is the classifier. If you draw a decision boundary between the virginica and versicolor, we are having some overlap of data, so that the linear classifier won't have the proper classification for this particular versicolor and virginica data. But if you draw a decision boundary between cetaso and other classes, we are having proper classification with the help of the linear activation function itself. That is example step function itself, we can able to get this particular black line. By increasing the activation function to a quadratic function or nonlinear activation function, we can able to get the decision boundary like this quadratic form. This is called as quadratic classification process, nonlinear classification process, quadratic or nonlinear classification process. This is the confusion matrix. In the confusion matrix, the predicted classes are represented as rows. The actual target class is represented as classes. If the target class is matching with the predicted class, we can state it as true positive. If it is matched with the negative, we can state it as true negative. Like this, we can able to draw the confusion matrix. From this, we can able to calculate true positive rate. What do you mean by true positive rate? Any idea about true positive rate? The true positive rate is equal to true positive divided by true positive plus false negative. Clear? This one, the true positive rate. Here in the region of convergence curve, in the y-axis, we are having true positive rate. The true positive rate is equal to true positive divided by true positive plus false negative. And in the y-axis, we are having false positive rate. The false positive rate is false positive divided by false positive plus true negative rate. False positive divided by false positive plus true negative rate. In this column, we have to consider. Like this, we are getting the true positive rate, false positive rate. Similarly, we will compute the precision, sensitivity, specificity, and accuracy. This is for the 2-class problem. If you are going for the 3-class problem, the confusion matrix will be like this. If you are going with 3-class problem, the confusion matrix will be like this. We should always get the region of convergence curve at this portion. Then only we can able to get a higher accuracy. If the convergence curve goes below to this pink line, that is a worst classifier. It has to go upper and upper, then only it is a better classifier. This is simple region of curve representation. This is the neural network combination. That is, we are having 4 input nodes, and then it is going for the classification process, 4 input features and 10 number of hidden neurons, and 3 output classes from this we can able to get the performance training set, error histogram, confusion matrix, and receiver operating curve. All this we can able to get. Epoch is the passing of all the training data is called as epoch. An epoch consists of many number of iteration. Here we are going with the scaled conjugate gradient weight updation function. This is the final performance curve of epochs and cross entropy results and error with instances. This is the training class, confusion matrix, validation, testing, and all confusion matrix. Training, in the training process, we will go up to the actual output value. Then we will go with the validation. With the training network, with the same data set, we will go with the validation process. Then we will pass the unknown input, that is comes under the test classification process, that is test confusion matrix. Then overall confusion matrix is the average of these three. This is the region of convergence curve representation, which is the curve drawn between false positive rate and true positive rate. Training, validation, testing, and all ROC curve. Now we will enter into the deep learning process. What is the purpose of deep learning here? We did classification with the help of multi-layer perceptron neural network. Then what is the reason we are going with the deep learning process? The answer is, in order to analyze the images in a deeper form and also improve the accuracy, we are going with the deep learning process. In the form of accuracy, if you have the state of comparison, the deep neural network, the deep learning process gives higher accuracy compared with the previous approaches. This is the state of comparison with the MNIST data set, and how the earlier approaches are getting the result, how the deep neural network will achieve higher result than that of these networks. The advantage of going with the deep neural network is there is no need to derive the hand-driven features like what we did in our iris flower classifier. In the iris flower classifier, we have extracted the features. Clear, sepal length, sepal width, petal length, petal width. The features has to be hand-driven features. With the hand-driven features, we are entering into the classification process. But in deep learning, we can able to directly give the image. From the image itself, it will directly fetch the features. It will directly fetch the features. MNIST dataset is the handwritten classification process, which consists of 10 number of images, and CIFAR10 is also having 10 number of color images. Like this, we are having different data sets. I'm giving the example for MNIST dataset. What exactly is deep learning is doing? Why is it generally better than other methods on image, speech, and certain other types of data? You can give the answer. The answer is, that is, in the MLP, we have fixed many number of hidden layer to extract the classification feature values. If you increase the more and more number of hidden layer, it will deeply extract the features based upon the extracted features, which will reach the classification process. So that in the deep learning, we are going to have more number of hidden nodes, more number of hidden layers, more and more number of hidden layers. The series of layers between the input and output do the feature identification and processing in a series of stages. Clear? I already mentioned that in deep learning, we won't give the manually extracted features. We will directly give the image. From the image, it will identify the feature automatically. The feature extraction takes place automatically in the deep learning process. The feature extraction takes place automatically in the deep learning process. That is the main advantage of this particular approach. Here, again, I am repeating, in the iris flower classifier, we have extracted the features manually. Then from the extracted features, we went to the classification process. But in deep learning, what we have to do means we will directly give the image to the classification process. From the image, we will the network itself automatically extract the features. The feature identification is done automatically in the deep learning process. And the another question will rise is, the multi-layer perceptron is around 25 years old. Then what is the specialty present with the deep learning process? That is, if you go with the deep neural network, we will have many number of weight value, many number of hidden layers. Like this, we will have many number of hidden layers, so that the weight updation becomes a complicated process. And see the number of parameters. For the simple iris flower classification, we require 10 number of features. 10 number of weight updation parameter. We require 10 weight parameters. If you include bias, that would also add. So that the number of parameters increases more and more if you keep more number of hidden layer. So that the weight updation, everything will become complicated process by going with the deep neural network process. We have always had good algorithm for learning the weights in the network with one hidden layer, but these algorithms are not good at learning the weight for network with more hidden layer. For the more hidden layer, this algorithm won't suit better. So that we have to go with some other concept. We have to go with some other concept for the weight updation and automatic feature identification process. So that we have to see how the weights are updated. If it is possible, we can able to go with the unsupervised feature learning process. That is, we know that in between the input and output layer, we are having many number of hidden layers. In the hidden layer, we have to go with unsupervised feature detection process. So that the idea of unsupervised feature learning, so that which identify the intermediate features for the classification process, which required for the classification process. The breakthrough is simple as deep learning neural network. ANN to deep learning, the weight learning algorithm for the ANN is dumb. They work by making thousands and thousands of tiny adjustments, and each making the network do better at most recent pattern, but behave little worse on many other. So that minutely we will do the weight adjustment and we'll go with many number of iteration, then only we can able to reach the higher accuracy. That can be overcome with the help of the deep learning process by introducing automatic feature extraction process. The deep learning, we will directly give the image to the classification process. From the image, the features are learned. Then it is going for the trainable classification process. In the previous multi-layer perceptron, we have extracted the feature. But in the MLP, instead of extracting the feature, we will frame an algorithm which design the feature learner. Clear? In the deep neural network, instead of design the feature, let's design the feature learner. Deep learning provides a way of doing it. Clear? In the previous iris flower classification, we have extracted the feature, then extracted feature is going for the multi-layer perceptron neural network classification. In the deep neural network, instead of extracting the features, what we are doing means we are designing the feature learner. From the image, the feature learning process takes place. Here, instead of design a feature, let us design the feature learner. Deep learning will provide the particular operation. So that the image, from the image, we will get the learned representation. From the learned representation, it is going for the classification process, which will provide the end-to-end approach, Image directly going for the classification process. There is no need to do the in between any feature extraction process in the deep learning approach. The deep learning is based on the concept of the fundamental is again the artificial neural network. In the artificial neural network, we will have multiple connected network. Our brain consists of billions of connections. In a similar way, we try to mimic in the deep neural network. Input, many number of neurons, then output. So that each layer will do that particular operation. The first layer, lower hierarchical layer, will provide the pixel we will feed, so that lower hierarchical layer will identify the edge. The middle hierarchical layer will identify the combination of edges. The top hierarchical layer will identify the object. So that image edges are identified, object for combining of edges, then it's directly going for the object model. With the MNIST data, we will see how the deep learning approach works. MNIST is a modified National Institute of Standards and Technology, which consists of large database of handwritten digits, which hold 60,000 training images and 10,000 test images for the 0 to 9 class. Totally 10 class problem, this one. Correct. Totally 10 class problem have 60,000 training images and 10,000 testing images. We have to do this particular MNIST data classification. This is the simple MNIST data classification approach. In the MNIST data classification approach, we are having the image, a simple 8-digit, as this eight representation, handwritten representation is shown here, which is an 28 cross 28 pixel representation, totally 784 pixel. This image hold 784 pixels. You already know that 0 will have the black representation, 255 pixel value will have the white representation. So that 255, the near to 255 will have the white representation, and remaining will have black will have the 0 representation. We have to classify this particular MNIST data set. For that, we are giving the input, hidden layer, and output. Just I am drawing one hidden layer here. With the one hidden layer, how the feature identification takes place, feature detection takes place, we will see now. This is another 8 image. This representation will have 9 cross 7 representation, input layer, hidden layer, output layer. We can have the image size. Whatever will be the image size, we can take it and we can able to do the processing. What this particular node is doing, we will see. Here we are identifying the self-organized feature detector. In the self-organized feature detector, we are having 1 to 63 because we are having 9 rows and 7 columns. 9 rows, 7 columns, so that 63 pixels. 9 rows, 7 columns, 63 pixels. And individual pixels you see means what you extract from this particular node means a strong positive weights are given to this particular horizontal line. And remainings are having low 0 weights. In order to extract the horizontal line, we have to give strong positive weights to this pixel representation, because the 1 to 7 will have one very minimum. From 2 onwards, we are having a minute black representation, so that up to 6 we are having the black representation. So that we have to give strong positive weights to this particular portion. And remaining we can give low or 0 weight, so that we can able to extract this 9 number horizontal flat representation. So that this flat representation is fetched by giving the weight component like this. It will send strong signal for the horizontal line in the top row. Strong signal on the horizontal line in the top row, ignoring everywhere else. Similarly, by seeing this particular node, what this particular node is doing means it's going to extract the vertical line. By seeing the vertical line, what are all the places we are having the vertical line? This 10th portion and 16, 17, then 20, 25 places we are having this vertical line. So that in those lines, we have to give the strong positive weights, and remaining places, the low zero weights are given. Low zero weights are given. Strong signal for the dark area in the top left corner. Strong signal for the dark area in the top left corner. So that this is the MNIST data. Now you can say what are all the features we need to extract from this particular data to classify the data more accurately. What are the features need to be extracted? What features might you accept a good NN to learn when trained with the data like this? The answer is we need to extract the horizontal lines. 7 will have the horizontal line, 4 is having the horizontal line. In some cases, 2 may have the horizontal line. So that we have to extract the horizontal portion, then vertical portion. 4 is having the vertical portion, 1 is having the vertical line, 9 is having the vertical line. So that we need to identify the vertical line. And some numbers are having the circle, curved portion. That curved portion also we can able to extract. Yeah. So that by extracting the in between, the hidden layers has to extract these features, then only we can able to do the classification more accurately. So that from this data set, we itself identified that the horizontal, vertical and circle portion has to be extracted from the data. With those deducted features only, we can able to classify the data properly. So that the vertical line portions 1, 4, 9 are having the vertical line portion, and 2, 7, 0 flat portion is there. So that horizontal line. And in some cases, we may have the small circles. Some cases we may have the small circles. But what about the position invariance? Because we are directly extracting the features, we need to concentrate on the position invariance also. So that at the first lower hierarchy, the first hidden layer, we can extract these particular features. Then in the second layer, we can able to go with the position invariance process. Similarly, higher layer will have the higher feature computation process. Yeah. This is our original data, which consists of 63 pixels. Among the 63 pixels, we are deducting the flat line, and this is from the first hidden layer. By going with the higher level detector, we can able to identify upper loop, lower loop. Upper loop means the position is in the top. The 9 is having upper loop representation. 8 will have both upper and lower loop. So that the first hidden layer will extract only the horizontal, vertical and loop representation. The next higher hidden layer, higher level detector, will identify the horizontal, vertical and also the loop location, where the loop is, whether it is in the upper portion or lower portion. Everything will be identified with respect to the next hierarchical layer, so that the feature deduction is good by going to the higher level hidden layers. Then finally, what does this particular unit do? Which will classify the data. So that in the multi-layer architecture, we need to go with feature deduction process. But we know that the input layer will have the image, the output layer will have the class information. Layer will have the image pixel values, and output layer will have the class information. In between, the layer has to do the feature deduction process. The two automatic feature deduction process. If you say the term automatic, so that we have to go with the unsupervised process, because here input, here only class. So that the last layer only we can able to go with the supervised classification process. In between, we have to go with the unsupervised approach. or in some cases we can able to go with the encoding process also, so that the multi-layer neural network capable of learning true underlying feature logic. Clear? True underlying layers and feature logics by doing automatic feature detection process. Automatic feature reduction process. But if the weights are not properly assigned, we won't have the proper classification process. So that we have to do the proper weight updation process. So that what we have to do means, from the input layer, we have to see what is the next layer output. With the help of next layer, we have to go with the next layer. For our particular handwritten example, first layer will do the horizontal, vertical, and loop representation. Second layer will identify whether it is upper loop or lower loop. Like this, individual layer will have the individual feature deduction process, so that the final layer will have the proper identification of the feature for all the data set present. From that feature deduction, we can able to easily do the classification process in a supervised way in a last stage. That is the training of the multi-layer neural network structure. So that in between, we have to do the auto encoding operation. Each of the non-output layer is trained to be an auto encoder. Non-output layer is trained to be an auto encoder. Basically, it is forced to learn good features that describe what comes from the previous layer. Basically, it is forced to learn good features that describe what comes from the previous layer. Here. So the input hidden layer encoding operation, while we are moving from hidden layer to output layer, we have to decode it to the original form. Moving from hidden layer to output layer, we have to decode it to get the original class representation. This is auto encoding decoding process. This is the basic idea, so that there are many types of deep learning approaches are available. The one of the example is auto encoding operation, which is doing the input auto encoding automatic feature deduction process, and the final layer which will perform the decoding operation, so that it will map it into the output layer, which is then top very fast growing field. There are various deep learning neural networks are available, like deep belief network, convolution neural network, recurrent network. The most recent network is mask RNN network. Like this, many algorithms are recently developed. And what is the limitation of this particular traditional neural network approach? Means, in the traditional neural network, all the layers are connected to all other layers, so that the number of parameters gets increased. If the number of parameters gets increased, it's difficult to fine tune all the parameters. And if you consider the input images having more number of data, which will also cause us more complication, that is much time consuming, and also which will make the system slower. So that we need to do proper deep learning approach to classify the given data. So if the number of parameters increases, which will cause us the overfitting problem. Number of parameters increases, which causes the overfitting problem, and also which is computationally intensive. And it is difficult to interpret the results, debug and tune and model, and also improve the performance. These are all the limitation of the normal neural network in the image recognition. Yeah. So that we are going to the convolution neural network. What is the advantage of this convolution neural network? Means, in the convolution neural network, we are going to separately concentrate on the individual features. Based on the features only, we are going for the classification process, so that the number of parameters are reduced with this particular convolution neural network structure than that of multiple number of layers. How does this convolution neural network is evolved? Means, again, it is basically evolved from the biological inspiration system. By seeing the visual cortex system, if you see any one of the image, first it will identify what is the edges present in, what is the horizontal, vertical line, and what is the diagonal edges are present. Among the combination of all these only, we can able to identify this particular object is an window or this particular object is an tree. Like that we will classify. So that what is happening in the visual cortex is the individual neurons present in the brain will identify. That is, here you can see retina is connected to the one particular area of our brain, and that particular area we will have one particular neuron. That particular neuron will identify the horizontal line. Another neuron will identify the vertical line. Another neuron will identify the diagonal edges. By combining weighted combination of this and performing activation function, that particular neuron is fired, so that we will identify that one as a tree or window. The similar thing is mimicked in an artificial way, which creates the convolution neural network. The similar thing is mimicked in an artificial way, which creates the convolution neural network. The convolution architecture consists of fully connected structure is then the last layer. The fully connected structure that does not scale to large image. The explicit assumption that the inputs are images, we have to assume that input should be an image, because in the visual cortex we are seeing only the image, so that directly we have to feed the image and encode the certain properties into the architecture and make the forward functioning more efficient. Vastly reduces the amount of parameter in the network, because we will perform the convolution operation so that the parameters are reduced. If the parameters are reduced, we can able to get less computation and less complexity, and then we can able to achieve our accuracy. For the 3D volume of CNN, we have to align in a 3-dimensional way, that is width, height, and depth. Application of CNN, the CNN mainly used in image recognition, image classification, object detection, recognition of the faces. And CNN image classification takes an input image, process it, classify it under certain category. And we know that the computer can see only the image in the form of pixels. So that based upon the pixel representation, if the image is RGB, we will have the 3-channel. If it is a grayscale, we will have this particular channel representation. Like this, it will proceed for the further processing. Convolution architecture, the layer pattern, stacks of convolution and ReLU layers, which will have the stack. That is one convolution ReLU layer, next, all will be cascaded together. So that convolution, ReLU, and pooling operations or takes place, and we have to feed the input and how the processes evolved, how we have to fix the number of parameters. Everything will be displayed here. This is the input. From the architecture, we can see that this is the input. From the input, we are fetching this particular process. This is a car image. From that, we are fetching this particular portion. Then it is going for the convolution and ReLU operation. Convolution layer, rectified linear unit activation function operation, then pooling operation. Again, the another portion is going for the convolution ReLU pooling operation. Then after completion of all feature learning process, after sufficient feature learning process, we have to again go with the fully connected layer. Fully connected layer is nothing but our simple multi-layer perceptron network. Simple multi-layer perceptron network. Every nodes present in the individual layers are connected to all the nodes present in the next layer. Final layer is softmax classification operation. This is the architecture of the convolution layer. This is the architecture of convolution neural network. Okay, input, feature learning with multiple convolution ReLU pooling layer, then finally fully connected layer. Before going to the fully connected layer, we have to convert this matrix form into vector form representation. We have to flatten this matrix representation, because here it will accept only the vector representation, individual feature based representation, so that we have to convert this matrix representation into vector form. Flattened input is going for the fully connected layer, then finally softmax classifier. Here, this is the architecture of convolution neural network. This is for our MMIST representation. If you consider the image of size 32 cross 32 or whatever will be the image size, it is going for the convolution operation. In the convolution operation, what we'll do? Image is going with the kernel filtering operation. Then convolved representation is feature map. 32 cross 32 is convolved with 5 cross 5 kernel, so that we are getting the features with 28 cross 28. Then it is going for the subsampling pooling operation. Then next convolution, ReLU, then pooling operation. Like this, it will extend. The finally, it is having the matrix of representation. This matrix of representation is entering into the fully connected layer. Fully connected layer, we will go with the softmax classification process. This is simple handwritten digit recognition process. How the individual layers works means, the convolution layer, the matrix volume of dimension and filter. I already mentioned that this is the image and the filter representation, image and filter representation, which will perform the convolution operation. After convolution, we are getting this particular output. The size of the final output is H minus FH plus 1 multiplied by W minus FW plus 1 multiplied by 1 representation. This is the output volume dimension. This is input filter kernel. This simply I am taking one particular, this is the portion fetched from an image which consists of this particular representation. Individual points will represent the pixel representation, that is multiplied by the filter or kernel representation. By doing the kernel multiplication, individual pixel points will be multiplied, then summed together. Individual pixel points will be multiplied, then summed together. By considering this rightmost portion, a 3 cross 3 kernel is placed onto this particular top portion. We have to start the kernel from here, this first pixel like this, then second pixel, then third pixel. This is called as a single striding operation. We are moving the kernel filter one by one, so that the single stride operation. With that, individual pixels are multiplied, then we have to perform the summation operation. By considering this particular portion, 1 multiplied by 1, then here 1 multiplied by 1, here 1 multiplied by 1. Totally, we are having 4 value here. With the help of convolution layer, we can able to enhance the image having the pixel value. Based upon the filter, the enhancement will vary. For example, this is the 4 handwritten image. This is the kernel. Kernel is nothing but the filter. We have to do the convolution operation because the kernel will have the flat representation, which will give more impact onto the horizontal line. We have the kernel as a vertical, which will have more impact on the vertical portion. Why means this pixel value and this pixel value multiplied and summed, so that which will have more value in that particular portion, so that the particular portion will be enhanced. This is another example. If you consider this mouse original image, we are extracting only this particular portion, so that this particular portion pixel value, this is going for the particular kernel filtering operation. In the kernel filtering operation, I am considering the pixel representation also like this. This is the visualization of the curve detector pixel representation, original image, visualization of filter image, that is multiplied together, and we will have the multiplication and summation as a larger representation. Like this, we are enhancing the individual field. And this is the identification of For identification, we have to use the 3 cross 3 kernel like this. For edge detection, like this kernel filters we have to use. You can see this is this is the identity matrix. With this, how the image is extracted. With the edge detection, how the images are enhanced. With the sharpening, how the images enhanced. With the blocks blurring, how the images are enhanced. With the Gaussian blurring, how the images is enhanced. Again, in order to find out the curved portion, if you use the same kernel, means this is the receptive field from the image, we are extracting this particular portion. In this particular portion, we are having the pixel value like this. If you keep the same kernel function as what we did earlier, we won't get the multiplication and summation value. The value becomes 0. So that in order to enhance, in order to identify that particular portion, we have to use the kernel with the similar pattern. Then only we can able to enhance only that particular portion. Here, this is the image representation. The previous case, we have extracted this particular portion. We are using the same kernel here also, so that by multiplying individual pixel points, then doing the summation, we are getting 0 answer is here. So that with this convolution operation, we won't get the proper output because you didn't selected the proper filter here. Clear? Stride is the number of pixels shift over the input matrix. When the stride is 1, we move the filter 1 pixel at a time. Stride 2 means we have to move the filter 2 pixel at a time. We have to move the filter 2 pixel at a time. This is the stride 2. We have to move 2 pixels at a time. Clear? We have to move 2 pixels at a time so that the image size is further reduced here. Image size is further reduced here. For example, the pink color represents the first portion. The orange, peach color represents the second portion. Here, we have moved 2 pixels away. So that this is called as stride 2 representation. Similarly, the below portion also. 2 pixels we have to move so that we will get the stride representation. Any doubt in this? How the convolution takes place, how the multiplication and summation takes place? And padding. That is, sometimes filter does not perfectly do the input image. The filter what you have chosen won't perfectly fit. At the time, we have to do the zero padding. With the help of zero padding, we can preserve the edges of an image. With the help of zero padding, we can also preserve the edges of an image. And next one is rectified linear unit. Rectified linear unit will have the activation function f of x is equal to max of 0, x. Then ReLU introduces the non-linearity. ReLU introduced the non-linearity in our convolution net. The real world data want our convolution network to act as a non-linear way, so that we are choosing this non-linear activation function. So that we are choosing this particular non-linear activation function. When x is less than 0, it will change the pixel value to 0. When x is greater than 0, which will retain the x value, which will retain the value. If you because we are doing the convolution padding operations, in those we may get negative pixel value. If you are getting the negative pixel value, that won't give proper classification process, and also real-time images cannot be represented in the form of negative pixel value. So that to overcome that one, we are using this rectified linear activation function. If the pixel values are less than 0, this activation function make it as 0. When the pixel values of greater than 0, which will make it as x, which will retain that particular x value. This is the rectified linear activation function value. This is the pixel representation after convolution and pooling. We can see the pink portion that is holding the negative pixel value. That is holding the negative pixel value. With the help of ReLU activation function, we are making it as 0. With the help of ReLU activation function, we are making it as 0. Then pooling. In order to reduce, downsample the image, we are using this pooling operation. Because if the image is too large in size, again, it will increase the number of parameters, computational complexity, computational cost. So that in order to overcome that one, we are going with the subsampling and downsampling operation, which will reduces the dimensional and also which plays the role to avoid the overfitting problem. With the help of pooling, we can able to avoid the overfitting problem. If it is overfitted, it is not generalized, it won't classify the unknown input properly. So that we have to avoid this overfitting problem. The overfitting problem can be avoided with respect to this pooling layer. There are various pooling operations available. In the spatial pooling, we are having 3 types. Max pooling. Among the pixels, we have to identify maximum pixel value. Then we have to retain that. Average pooling, among the pixels, we have to do the average of it and then we have to retain it. Sum pooling, we have to sum all the pixel value. This is a simple max pooling operation. We are using 2x2 filter and 2 stripe. Max pooling with 2x2 filter and stride 2. So that this is our 4x4 representation. This 4x4 with this 2x2 filter representation, we will get only the 2x2 value. So that we have downsampled the particular image. So that the number of parameters gets reduced. Computational cost reduced, computation complexity reduced, computational time also reduced. For that only we are going with this pooling operation. Max pooling, I'm using 2x2 filter with 2 stripes so that I'm placing the filter here. I'm placing the filter means we have to consider this 2x2 portion here max pooling. So that maximum value we have to identify. 7 is the maximum value, retain the 7 value. And here the maximum value is 9. In the red portion, we are having the maximum value 8. And in the green portion, we are having the maximum value 5. And next one is average pooling. In the average pooling, we have to make average of this particular representation. 10 plus 16 divided by 4 is equal to 4. In a similar way, every portion has to be repeated. Here, so that max pooling, average pooling, sum pooling means we have to sum it. 10 plus 6, 16 is in this particular case. That is the max pooling operation. In order to downsample the image, we are going with this pooling operation. And fully connected network, after the convolution, ReLU and pooling operation, we have to flatten our matrix into vector. We have to flatten our matrix into vector, feed it into fully connected layer neural network. Then the fully connected neural network acts like the feature mapping to output layer. It will perform the classification with the help of the softmax classifier. That is the functioning of the fully connected layer. In the previous portions, we have seen, we have given an image. From the image, we did the convolution operation, ReLU operation, then pooling operation, then the downsampled values are going for the flattening operation. Flattened vector is entering into the classification process. With the help of softmax, probability-based classifier, we can able to classify the data to any one of the class. Input volume, convolution, either stride 1, stride 2, ReLU, then pooling operation, then output volume, flattening operation. Based upon the output volume here 14, 14, 3, multiply all these, we will get the output volume 588 multiplied by 1. This is the flattened representation. This flattened representation is entering into the fully connected layer. 20 multiplied by 1. Like this, we may have many number of fully connected layer. Then we can classifying it. Then we are classifying. For handwritten representation, we are having 10 number of classes here. Handwritten representation, 10 number of classes here. Image, the particular portion, feature mapping with the help of convolution ReLU pooling. Then convolution ReLU pooling, feature map, fully connected network, then output layer. Fully connected network, then output layer. The summary is we have to provide the input image directly into the convolution layer. There is no need to extract the feature what we did in our iris flower classification. Here we can directly give the iris flower image, or we can able to directly give the handwritten image. All the images can be directly given to the convolution layer, and we have to choose what is the kernel filter and how many number of strides we have to give, and whether we need to padding or not. The advantage of going with the padding is if the filter size is not matching with the input image size, we have to go with the padding operation. And also padding will will preserve the edges. Then to avoid the negative pixel value, we are going with the Rayleigh activation function. Then with the help of pooling operation, we can able to reduce the dimension. With the help of pooling operation, we can able to reduce the dimension. Like this, we may add many number of layer until satisfied output. Then if you are getting the satisfied features, we can able to go with the fully connected layer. With the fully connected layer, as like multi-layer perceptron, which will perform the classification operation. Then we can able to classify the data. This is the summary of convolution neural network. Any doubts and clarification, you can ask. If you're having any doubt, you can ask. One question, whether we can use our own customized filter in CNN. Yes, we can able to develop our own customized filter, and then individually we have to feed that particular kernel. Then we have to get the convolution layer output. Individually, we can able to do. Another question is from the public data set, how can Another question is from the public data set, how can we separate the training and test data set? Mostly in the MS data set, they are providing separate training data and separate testing data. You can directly use it. 60,000 number of training data and 10,000 of testing data, they are directly providing. You can download the MS data set and you can directly have the training and test data set, and you can directly use it for your algorithm. Mostly for all the open access data, they are providing training and data set separately. For deep learning, if you use the GPU, which will give a better result. If you are not having the GPU, you can go with the cloud-based. You can able to go with the cloud-based GPU operation like Colab, NVIDIA, and all. They are providing the cloud-based hardware accelerator. With the cloud-based hardware accelerator, you can able to perform the classification process. How to decide? The next question is how to decide the number of layers and number of neurons in each layer. That I mentioned for the input layer. If you have the number of how many number of input features if you're having, that has to be considered as number of input nodes in the input layer. Then in the output layer, how many number of output class if you're having, that many number of nodes we should have in the output layer. Here, the number of input is equal to number of nodes in the input layer. The number of outputs is equal to number of output nodes in the output layer. In between the hidden layer, we can do our modification. There is no formula and procedure is available to decide the layers. That is our choice. That is, we have to know by first we have to give 10 number of first we have to give minimum number of hidden layers. Then we have to see the accuracy of our output. If it is not reaching our required accuracy, you have to increase the number of layers. By increasing the number of layers, compulsorily we can able to achieve the higher accuracy. Yes, NVIDIA and all, the next question is, the cloud-based GPU requires payment. Yes, but Colab, we can able to use it freely. Colab, Google Colab. NVIDIA and all, we have to do the payment, but Google Colab, we can use it freely. The next question is, can we give time series data as an input to the CNN for prediction and classification? LSTM you have to use. Okay, for the time series data analysis, LSTM network you have to use, which will provide better result for the time series data representation. In order to do the audio based application, we need to convert the audio signal into images with the help of spectrogram. We have to convert the signal file into image file. Then you have to feed the image file to the deep neural network approach, so that you will get better result. What happens if we increase the filter size? Will the output accuracy increases? If you increase the filter size more means, if you use higher filter size means the impact of image pixel will get reduces. So that we have to use the proper filter size. Then only we can able to retrieve the original image. Otherwise, the filter will have more impact. So that proper filter size is required.
Hello.
Yes, ma'am, I can hear you, ma'am.
Okay, Shivappriya, thank you. So if there is no question means we will finish the session.
I have answered all the questions. That's no other questions in the chat window other than this.
Okay. So,
Okay, ma'am.
So dear participants, so due to some technical issue, so during the start of the program, there was some technical issue. So that's why some problem. So Shivappriya ma'am directly start the session. So it's very sorry for this interruptions and all any troubles you made during this session. Okay, anyway, we'll so if you want if you have any doubts, you can easily you can mail to Shivappriya ma'am also, and also to our all the mail IDs which given in your poster, right? Okay, so Shivappriya ma'am, you gave a very much interesting session and thought-provoking session. You have explained a lot that is from the basics to image classification. that is from your artificial neural network basics to deep neural networks. So it will be very much useful for the participants to do research works in all this neural network related applications, especially in the healthcare industries. So very much useful to all. Definitely, it will be very much useful for all the participants. Thank you, ma'am. Thank you for this thought-provoking session. Participants, the tomorrow's session will be started at 10:30 a.m. So the joining URL will be sent through your mail and your Telegram link. Thank you for the participation. Thank you. So feedback link already posted in both YouTube live as well as in this chat box. Thank you all. Thank you for your participation.
Ma'am, in YouTube there is no feedback link. Will you please post it?
Shiva. ரெண்டு டைம் போட்டேனே பாரு இல்ல நீ செக் பண்ண.
No, it is not available.
இல்ல அப்படின்னா மேபி உன்னால தான் போட முடியுமான்னு பாரு, நான் உனக்கு லிங்க் அனுப்பியிருக்கேன். நான் 2 தடவை போட்டேன்.
ஓகே மேம்.
வந்துருச்சு பாரு. வந்துருச்சு. செக் பண்ணிக்கோ, இல்லைன்னா நீ ஒரு தடவை போட்டுரு இதுக்கு க்ளோஸ் பண்றதுக்கு முன்னாடி. ஹலோ சிவப்பிரியா.
Okay, no problem. Thank you, ma'am. Thank you for attending.
ஹலோ சிவப்பிரியா.
மேம் போட முடிச்சவங்கனால டிஸ்ப்ளே ஆச்சா? எனக்கு
நான் போட்டா எனக்கு காட்டுது. அத நீ ஒரு தடவை போட்டுரு. மேபி ஹோஸ்ட் தான் போட முடியுமான்னு தெரியல. அதுக்கு தான் நான் இன்னும் டிஸ்கனெக்ட் பண்ணாம இருக்கேன். யூடியூப்ல நான் 4-5 தடவை போட்டேன். இதுல சாட் பாக்ஸ்ல வந்துருச்சுன்னு நினைக்கிறேன். யூடியூப் மட்டும் பாரு. நீ ஹோஸ்டா இருக்கறதுனால அது உன்னால தான் போட முடியுமான்னு தெரியல. உனக்கு மெயில் பண்ணியிருக்கேன் பாத்தியா? மெசேஜும் அனுப்பியிருப்பேன்னு நினைக்கிறேன். ஹலோ